Hey guys, what is going on? Welcome back to another episode of Physics Explained, and today we're back with another Physics in 5, and as you can see on the board, we're actually starting our Newtonian Mechanics series now, and to begin with, we're going to be looking at 1D kinematics. So let's get started. So the first thing we're going to look at here is average velocity. Now if you remember from the earlier episodes in this series, we talked about the difference between velocity and speed. Velocity is with a direction, and we generally consider right across the page to be the positive direction. So in this instance, the object on the board is travelling with a speed in the right direction, which is a positive velocity. Now I could have quite easily drawn this the other way and it would have been a negative velocity. So the magnitude, the actual number, is what counts in terms of how fast an object is moving, and the plus or minus determines which direction it is. Now why do we give it the letter x? Because we're concerned with motion in one dimension, and generally we consider the x-axis to be the 1D axis, x and y to be the 2D axis, and x, y and z to be the 3D axis. So here we have an object at a point P with the coordinate x1, and it's travelling with some speed unknown in this direction, which gives us our velocity, and it travels to a point P2, which we give the coordinate x2. And it does all this in a certain time. So at time t1, it's at x1, and at time t2, it's at x2. And the average velocity here, given v have x as in the x direction, is given by the change in position. So x2 minus x1. We always go with the end position minus the original position. That gives you the change in position. And t2 minus t1 again in a certain time frame, and this is the time interval and the distance interval given for this object. This is given this symbol, the delta x delta t symbol, which literally means the change in x and the change in t. Now this is quite often given in terms of a graph. So here we have position against time, and if we measure the individual positions of the object at a certain time, we can plot this graph. Now this is for an object that was stationary to begin with, and it's moving at an accelerating rate with time, what would essentially be a straight line past this point of a constant velocity. The gradient between x1 and x2 is the average velocity between this time. Now you can see it's not actually the individual velocities at different points in time, that's the instantaneous velocity, which is what we're going to get onto next. Now the instantaneous velocity gives us the velocity at a certain point in time. So if you were driving along, say, in a car and you looked at the speedo, at that given point in time, you may be travelling 30 miles an hour, 60 miles an hour, whatever, but that is the instantaneous velocity. But if you measure the velocity or the speed over an entire journey, then that's given by the time it took for you to get from point A to point B. The instantaneous velocity is given by measuring the change in position over a very small time interval by moving that second point closer. This is denoted by the limit as t approaches 0. So as we make the time interval between the 2 points very small, the change in x, the delta x, is given by the derivative of the x against time graph. Green line with a change in position over time, so it starts off accelerating, it reaches a constant velocity here, it begins to slow down, and then it's stationary again. Then the derivative, or the instantaneous velocity, is given by this tangent to the slope. Now a tangent to the slope is the gradient of a slope at a given point on the graph. So here it would be given by the gradient of this slope, and that is the instantaneous velocity at that particular time interval. For us to find a value for the instantaneous velocity, we either have to have a function of x that has some variation of time in it, or we have to plot an xt graph and measure the slope of the tangents. It's usually that we find the average velocity and assume that it gets there very quickly in most equations, and that's why we usually give the equation v equals x over t, which is given as an average velocity. So there you go guys, that's instantaneous and average velocity explained for you. Next week we'll be looking at average acceleration and instantaneous acceleration, and then we'll be moving on to look at other aspects of Newtonian mechanics. If you enjoyed what you see, hit like, hit share, spread the news. You can find more information out at www.physicsexplained.co.uk.